hemisphere, I don't know why your book really wants you to focus on it, but it's just half of all of the other previous formulas. So the volume is 1/2 times 4/3 pi r cubed. Simplify before we multiply. The 2 down here and the 4 up here are going to cancel out. We're going to be left with 2 up top and then thirds pi r cubed. So that's the volume of a hemisphere. The surface area the surface area of a hemisphere, we have cut the hemisphere in half, so we can take the surface area of a sphere and multiply it by a half. So that's going to be 1/2 times 4 pi r squared. But also realize that we've now added this circle right here. And this circle still has the same radius as the hemisphere. So it's going to be plus pi r squared. So 1/2 times 4 is going to be 2 pi r squared. And then we've got plus 1 pi r squared, right? There's only one of those guys there. So it's going to actually combine to 3 pi r squared just because you've added that extra circle surface as you've sliced it in half. So technically the surface area is this half of the hemisphere plus this circle. Not in your formula packet. Neither of them are in your formula packet. You need to be able to understand the relationship of the formulas that you do have to what you know as the idea of a hemisphere. Okay, so those are all of the formulas. Again, most of them are in your formula packet. Knowing how to use your formula packet with 3D geometry is going to be key here. So having it out as you're doing your work is definitely what I recommend doing. Let's go ahead and just practice some three-dimensional geometry. An ice cream cone has the shape of a right circular cone with a radius of 3. Pause. Draw the picture. A right circular cone, or an ice cream cone, is a right circular cone. Right just means that, that the vertex is not skewed. For instance, I could draw a cone that looks like this, like a tornado, and that is not a right circular cone. This is my best way of drawing a right circular cone, where that vertex is directly below the circle. That's all that means. So drawing out your right circular cone, it has a radius of 3, so I went ahead and just drew that in, and a height of 8. Boom. Hey, we want to calculate the volume, so I'm first going to write out my formula. Remember that it is your recipe. It tells you what pieces of information you need in order to be successful in this problem. We have the radius, we have the height, so we don't need to solve for anything, which sometimes we do, but it's nice to have the formula because then we can say, oh, well, we have that and we have this, and so we just need to plug it in and go. So 1/3 times pi times 3 squared times 8. Please, 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 please remember that when you put in this formula that you are also multiplying by the exact value of pi, which is in your calculator. So go ahead and calculate that out. You should have gotten something along the lines of 75.4 centimeters squared. In order to calculate the surface area, what we should be thinking in our head when we're being asked to do this is we need to figure out what the surfaces are. Well, the surface area is the area of the circle. So I'll do like area of the circle plus, and then I'm going to call it LA. L is lateral, A is area, so it's your lateral surface area. Area of the circle is pi r squared, which we can find in our formula packet. The lateral surface area we can also find in our formula packet. It is pi r, S. And in your formula packet, it describes S as being like the diagonal height or something like that, like the lateral height. And remember that this is S. So we have the radius. It is 3. We do not have S. We need to solve for S. And so then this is where trigonometry and right triangle trigonometry really do come into play a lot with our three-dimensional geometry. So hopefully you'll realize that the radius and the height here have a relationship of a 90-degree angle, which means we have a right triangle. In order to solve for the missing length of the right triangle, we just need to do the Pythagorean theorem. We have a right triangle, we're only talking about side lengths, so this is where we would use Pythagorean theorem. 3 squared plus 8 squared equals s squared. I would leave it inside of the square root because we really are only using this s value in order to solve for the surface area. So solve for it, but leave it inside the square root so it'll just be easier to deal with the exact value later. 3 squared is 9, 8 squared is 64. Add them together, we get that s squared is equal to the square root, s squared is equal to 73, which means that s is equal to the square root of 73. Okay, so now I can use that to plug it into my formula. I've got pi times the radius squared plus pi times the radius times the lateral height. Go ahead and plug that all into your calculator and tell me what you get to 3 significant figures. Making sure that you plugged in pi using the exact pi on your button or on your calculator, exact pi button on your calculator. Also making sure that you did the square root of 73 instead of an approximation of it. Making sure that you multiplied accordingly, added accordingly, are all very good things to check if you realize that you didn't get the right answer here. Okay. Example 12. We've got a triangular prism. So we are asked to calculate the volume here. The volume with any prism is going to be area of the base times the height. And this is a great example again that the height is not how tall this prism is. The height is always the distance between the two bases. And so since the two bases are triangles, what's the distance between those two bases? It's labeled here as 5. So height is 5, area of the base. The base is a triangle. So we could do 1/2 times base times height. Absolutely, we would have to solve for the height here in order to do that. And we will eventually need to solve for that anyway because we're going to find the surface area. But we could also use our trig formula for the area because we have this angle here, which is 60. And so we could do 1/2 AB sine of C, where we do 1/2 times A, which is 2. This length right here has been represented over here, which is very common where they give you some measurements on one side and some measurements on the other, and you have to know what measurements are the same. So I know that this length and this length are the same, so I know that that is also 4. You can read that. So your second length would be 4, and then this angle C is the angle that's in between those two side lengths. So then we get to do sine of C. You could have also done the Pythagorean theorem, and the Pythagorean theorem, if we do, I'll call this H, actually I'll call it X, just to not be confusing. X squared plus 2 squared equals 4 squared. You'll get that x is equal to the square root of 12. So you could have also done the square root of 12 times 2 times 1/2, which comes out as the square root of 12. And so the area of the base here, sine of 60. So the area of base is the square root of 12, or you could write it as 3.46. Either way. Just realize that if you wrote it as a decimal, that you're writing it as a decimal to keep your place on the page of what that value is. But you do need to make sure to use the exact value in your calculator. It's so important. It's so important, guys. It's really important to use the exact value in your calculator and not a rounded value. Please make sure to do that. Okay, so your volume is going to be this 3.46 guy, and then multiply it by the height. So I'm going to take that previous answer that I found in my calculator and multiply it by 5, and I get 17.3 for my 3 significant figures. Centimeters cubed. Okay. We are now going to calculate the surface area, and I'm going to break it down into all the surfaces that I have. The surface area is going to be equal to 2 times the area of the triangle, which I've already solved for the area of the triangle up above here, right? So that's kind of nice that I just get to use that again. And then it's going to be plus this rectangle, so this base rectangle, so it's going to be 2 times 5, plus, and then this rectangle that's here to the side is going to be x times 5, which is your square root of 12 times 5, plus, and then this long one right here, which lays against the hypotenuse, and that's going to be 4 times 5. Or just realize that if you found the perimeter, square root of 12 plus 4 plus 2, and then multiply by the height, it would still give you the same answer for that lateral surface area. So we've got 2 times that 3.46 guy, and then we add 10, we add 5 square root of 12, and we add 20. Go ahead and add those all up and tell me what you get. You should get 54.2 centimeters squared. All right, this last example, example number 13, we're going to go ahead and do together in class tomorrow. I think it would be a good idea to see if you can get as far as you possibly can on this example. And if you get stuck, it's fine. But it's a good idea for you to be able to see how far you are on your puzzling ability, right? So remember that all of your tests, all of your quizzes are all going to be problems that you haven't necessarily seen before. And it's good to start challenging yourself on working on problems that you may not have seen before. You have all the tools available to you that you need in order to solve for this. This has right triangle trigonometry and non-right triangle trigonometry in it, so this would also be a great review for your trig. And if you start working on it now, and then when we do it together in class, maybe you'll make some more connections and have some more ideas of it in class. So I would recommend that you try and do a little bit of it on your own tonight when you're done with this. So then that way, the next time I see you guys and we work on it in class, you just feel a little bit more confident and comfortable. All right, guys, great job.